In this video for section 8.1, we're going to introduce the idea of a confidence interval. So here's an example. The HealthStar Energy Drink Company makes and markets a popular drink that is sold in 12-ounce bottles. A manager in the quality control lab selects a random sample of 100 bottles and measures the volume of liquid in each. They find a sample mean of 12.79 ounces, and we're going to assume that sigma, our population standard deviation, is known to be 0.2 ounces. So the value of 12.79 is our best guess for the population mean. And we say that this is the best point estimate of the fill amount of each bottle. So we know that if we were to collect a different sample of 100 randomly selected bottles and calculate their mean fill amount, we would get something slightly different than 12.79 ounces. Probably it will be close to that, but probably not exactly 12.79. And this is because there is variation from sample to sample, which is also called sampling error. So because samples are going to be slightly different, taking slightly different individuals, we're going to get a different value for the sample mean. So instead of having a single value for the point estimate, we might want to report a range of values that most likely includes the mean of the population, and this is called a confidence interval. So this picture shows what a confidence interval looks like. It's a range of numbers with a lower limit and an upper limit. So we're saying that our population mean is most likely between these two numbers. The point estimate is in the middle of the confidence interval. So we are going to create confidence intervals with different confidence levels. The one that we're going to use in this class are 90%, 95%, and 99%. As the confidence level decreases, the interval gets more narrow. So there's a trade-off if we want to be more confident, so go from say 95% to 99%, then our interval needs to become wider because we have a wider range of possible values for the population mean. So we can use Minitab to find confidence intervals. For the example above, if we use Minitab to find a 95% confidence interval, we find that it is 12.75 to 12.83 ounces. And you're going to see these in Minitab in parentheses. The parentheses just means an interval. So we have our smaller number first and then our larger number. This tells us that the machine is most likely overfilling the bottles because our interval does not contain the number 12, and that tells us that 12 is probably not the population mean. So when we have a confidence interval, the way that we interpret it is that if we were to select many different random samples of 100 bottles from the population and construct a confidence interval for each, approximately 95% of the intervals will contain the true population mean. So this example picture here is for proportions, but it works the same for means. The green line represents our true population mean, and each of these is an interval, a confidence interval constructed from sample data. So we see that most of the confidence intervals do contain the true population mean, or the green bar. There's 20 confidence intervals here. 19 of them contain the green bar. This confidence interval right here does not contain the green bar. And so that's the 5% that does not contain the mean. And what this means is that for this sample, we happen to get a lot of values that were significantly higher than the mean. And so that gave us an interval that was higher than the true population mean. So out of the 20 intervals, 19 of them contain the true population mean, one of them does not. So that's 95%. When creating confidence intervals, we need to pay attention to whether the population standard deviation is known or if we are using a standard deviation that is estimated from a sample. If the population standard deviation is known, then the calculation is based on the normal distribution. And in Minitab, this is called Z. So we're going to be using Z in Minitab. And the problem that we are given will refer to the standard deviation as population standard deviation, or it could use the symbol sigma, which as we know stands for population standard deviation. If the standard deviation is not known, then we are going to be using a sample standard deviation. And this is based on a different distribution, not the normal distribution, but it's similar. It's called the t-distribution. So in Minitab, we're going to be selecting t, and we will use this if the problem refers to the standard deviation as sample standard deviation or S. We remember that we use the letter S for sample standard deviation. So let's look at example 8.1. Administrators at a university are interested in estimating the average amount students spend on textbooks during the first 4 years at the university. They take a random sample of 200 students and find a sample mean of $5,230. Past studies have indicated that the population standard deviation is $500, and we want to find a 90% confidence interval for the population mean. So since they're giving us population standard deviation, this tells us that we're going to use Z. So let's go to Minitab. We're going to use one sample here. We're going to go to one sample and select Z. Now what I need to do first is change this from sample data in a column to summarized data. Then I'm going to enter my sample size, sample mean, and the known standard deviation. My sample size was 200. My sample mean was 5,230. And my known standard deviation was 500. Then I click on Options to select the confidence level that I want. It's going to automatically be set at 95. I can change it to 90 or 99. For this problem, we wanted 90. Then I'm going to click OK. And it gives me this box right here. So my 90% CI stands for confidence interval for the mean, is $5,171.85 to $5,288.15. So this tells me that my mean is probably between these two numbers for the population. It's not definitely between these two numbers, but probably. The interval probably has captured the true value of the population mean. So the interval here is $5,171.85 to $5,288.15. Now let's look at example 8.3. An internal auditor for a retail grocery store is interested in the difference between customer bill and true cost of the items purchased. A sample of 20 transactions is selected, so that's our sample size. A sample mean difference of 77 cents and standard deviation of $1.19. Now it doesn't say the word population or sample, but because the sample here of 20 is describing both the sample mean and the standard deviation, that's a pretty big clue that this is a sample standard deviation. So if it's a sample standard deviation, we're going to use T. And we want to find a 90% confidence interval estimate. So let's go back to Minitab. Now this time we're going to go to one sample and click on T. Use Summarize Data and enter our sample size, sample mean, and sample standard deviation. My sample mean was 77 cents, so 0.77, and standard deviation 1.19. Again, go over to Options and select the confidence level. This problem is asking for 90%. Then click OK. And here's our confidence interval, 0.3099 to 1.2301. As always, make sure that you're rounding numbers the way that MyLab wants you to round when you input your answers. So this would be my answer. So we are 90% confident that the true population mean is somewhere between about 31 cents and $1.23.